So we have completed question number 2, and now we have to start with question number 3. So here in question number 3, the hydrogen halide HCl, HBr, and HI, hydrogen chloride, hydrogen bromide, and hydrogen iodide are all colorless gases at room temperature. The hydrogen halide can form by reacting the halogen with hydrogen. So it means that hydrogen, when reacts with chlorine, forms HCl. In the same way that hydrogen reacts with bromine to form 2 moles of hydrogen bromide. And in the same way, when hydrogen reacts with iodine, we would get 2 moles of hydrogen iodide. Describe and explain the relative reactivity of halogens down the group when they react with hydrogen to form HCl, HBr, or HI. So if you recall the halogens, and if you recall this trend, so we can write the relative, they are asking about the reactivity of halogens, not the hydrogen halides. So the relative reactivity of halogens decreases down the group because the electronegativity decreases and there is less attraction to the electron that is being added. So this is the answer. Now, next part. HCl is a product of several different reactions. Some of these are shown in figure 3.1. So write an equation for the reaction 1. So if you look at the reaction 1, here it is silicon chloride reacting with water. So if you recall this, in this reaction, silicon chloride would react with the water, forming silicon oxide and 4 moles of HCl. So to balance the equation, I have to put 2 over here. And the equation is balanced. Okay. Now, in reaction 2, NaCl reacts with concentrated sulfuric acid to form HCl and sodium hydrogen sulfate. Right? When NaBr reacts with concentrated sulfuric acid, the product include bromine and sulfur dioxide. So they have given you all the information. Identify the type of reaction that occur in each case completing table 3.1. Explain the difference in these reactions. Okay. So when sodium chloride reacts with sulfuric acid, they have told you the products that are forming is sodium hydrogen sulfate and HCl. So if you see, this is donating the H positive ion, right? So if it is donating the H positive ion, so I can call this one an acid. So this, the type of reaction would be acid base reaction. Is this understandable to everyone? Yes, is this clear? Now, if you see the second reaction, when sodium bromide is reacting with sulfuric acid, what they are informing you that the product formed over here is bromine and sulfur dioxide. So if you recall, at first the same reaction would occur, that sodium hydrogen sulfate and HBr. Then this HBr reacts with sulfuric acid. We have this reaction discussed in our classes as well. Bromine is formed along with sulfur dioxide gas and H2O. So again, the first reaction is, because here it is behaving as an acid. So the first reaction that is occurring over here is a acid-base reaction. Then the second reaction, if you see here, bromine is -1 and turning into 0. And sulfur is +6, which turns into +4. So see, bromide ion is oxidized to bromine and the sulfur is reduced from +6 to +4. So we can further recall or write that it's a redox reaction. Is this clear? Okay. Now, here sulfur is behaving as an acid only. Here, first sulfuric acid reacting as an acid, but then here it undergoes reduction.
सर
Then, yes,
सर ऊपर वाले में बेस क्या है NaCl वाले में?
basically chloride ion is the base because it is accepting the H positive ion.
अच्छा सही है.
So here, if you see, sulfur is changing from +6 to +4, which means undergoing reduction, which means it's an oxidizing agent. So it is behaving as an oxidizing agent, but it is not behaving as an oxidizing agent with HCl. So the explanation would be over here that sulfuric acid is strong enough to oxidize bromide ion, but not strong enough to oxidize chloride. Is this clear to everyone?
फिर थोड़ा ऊपर करिए, छोड़ लेना।
Yes. Okay. Now C part. When heated with a Bunsen burner, HCl does not decompose, whereas HI forms hydrogen and iodide. So it is suggesting that when HCl is heated using that Bunsen burner, no reaction would occur. That heat, that amount of heat is not letting the hydrogen chloride to break. But when we use hydrogen iodide and we heat it using Bunsen burner, it decomposes to give hydrogen and iodine. So what these two observations are indicating us? Yes.
तो thermostability.
Okay. So it is actually indicating as the bond strength of HCl and HI. So we can conclude and state that the hydrogen chloride bond is stronger than hydrogen iodide bond. Is this understandable to everyone?
सर अगर एक से ज्यादा मार्क का आता है तो फिर हम इसकी मतलब इसके पीछे का रीजन क्या देते हैं?
फिर हम then the reason would be it is because the size of the chloride is smaller, and
सही
as
है,
a result the bond length is smaller, which makes the hydrogen chlorine bond stronger than hydrogen iodide.
सही है।
Okay. Now the D part. The hydrogen halide dissolve in water to form strong Bronsted-Lowry acids. The concentration of the strong acid can be determined by titration. What is meant by the term strong Bronsted-Lowry acid? So they are actually asking you two things: strong and Bronsted-Lowry acid. So I would write that
कंप्लीटली जो आयोनाइज करता है।
that is a strong acid. Bronsted-Lowry acid is proton donor and strong refers to that. Now the statement which you said, Abdullah, that it is.
तो सर H+ तो सारी देते होंगे ना इसमें?
Yes, but if it's a Bronsted-Lowry acid, so we must write that it's a proton donor.
सही है,
So that it is completely ionizes in aqueous solution or in water. On figure 3.2, sketch the pH titration curves produced when 0.1 mole of NaOH. So if you recall, NaOH is a strong base. Is added to 25 centimeter cube of 0.1 mole HBr to excess. So it's a strong acid. Okay. If you write the equation of NaOH and HBr, you would find that NaBr and H2O is formed. And if you have look at the equation have a 1 mole of each the substance, and the equation is completely balanced, right? So it means if we are using the same concept of hydrogen
सर आपकी आवाज नहीं आ रही.
Now, am I audible to everyone?
Yes, sir.
So this is a curve between strong acid and a weak base, then in this case, if you recall, the end point is below 7. So the midpoint of vertical line is must be below 7, right? And if 25 centimeter cube of a base is added, then we made a straight line.
फिर समझ नहीं आया, वापस समझा दो।
Which part you didn't understand, Abdullah?
और शुरू से ही।
Okay. The first graph is clear or not?
नहीं सर, फर्स्ट वाला नहीं।
The first one is also not clear?
नो।
Okay. See, we have a strong acid and a strong base. We discussed this in the lectures that when there is a strong base and the strong acid, then the end point of the titration is at 0.7.
सही है।
So the midpoint of the vertical line is at pH 7. See over here.
सही है।
And both have the same concentration. So if the volume of acid would be 25, then the volume of base that would be added is also 25. So we would make a straight line at 25.
ये हमें मोल से पता चला।
Yes, from the balance equation, because you see these have a equal number of moles. So if 0.1 is the concentration of both the solutions, and if there is a 25 moles of HBr, so it's obvious that 25 centimeter cube of NaOH is also needed.
और सर अगर थोड़ा कम ज्यादा होता तो हम उस हिसाब से ग्राफ को फिर मतलब
Yeah, we take the ratio. Yes.
सही है। मतलब एग्जैक्ट
So
होना
that's
तो
why
जरूरी नहीं होता ना।
no, it must be exact.
अच्छा, सही है।
So we are making the straight line at 25, and we keep in mind that its midpoint would be at pH 7. Then it's a strong base. So the line is almost horizontal, a very little slanted, and it's a weak acid, so line is almost horizontal and a little slanted. Now, in the second case, we have a strong acid and a weak base. In this case, the endpoint is below 7, so the midpoint of the vertical line is below 7. The ratio is 1:1 again. So if we have a same concentration, so the same volume must be used for ammonia as well. Okay. So it means again the straight line is going to be formed at 25. And see, now its midpoint is around below 7, right? And it's a strong acid over here, so it would be very slightly slanted, and it's a weak base, so it would be like this, a little more slanted than the strong base. It would be like this. Yeah, is this clear?
Sir, I have a question.
Yes, Variza.
सर अगर रेशियो 1:1 नहीं होता तो फिर हम किस तरह से बनाते हैं ग्राफ? फॉर एग्जांपल 1:2 हो गए।
For example, here I have using sulfuric acid with NaOH, right? If you make the equation, it would be sodium sulfate and H2O. So I'm just changing this acid with sulfuric acid, right? So if I balance the equation, it would be 2 moles of NaOH, right?
Yes, sir.
So if its concentration is 0.1 and its volume is 25, and the concentration of NaOH is also 0.1. So what I already know that I need a double moles of NaOH, right?
Yes, sir.
So it means the volume of NaOH must be 50. Right?
Yes, sir.
So it means this would tell me that if I am going to NaOH in this one, where there is a sulfuric acid, so starting from the 0, wherever there is a 50, I would have to make the straight line at the volume 50. Because 50 centimeter cube of NaOH is going to be added.
Okay, sir. Clear हो गया.
Yes, is this clear to everyone else as well?
सर हम
Yes. Can you repeat your question, please?
सर 75 पे नहीं करेंगे because 50 plus 25.
No, 50. Here, if you see, here what is the volume of NaOH? So volume of NaOH is 50 only. 25 is already in the flask and on the x-axis I have a volume of NaOH. So I need 50 centimeter cube of NaOH. So the straight line would be drawn at 50 centimeter cube, and as both are strong, so the rest of the line would be like this. Is it clear, Abisa?
Yes sir.
Okay.
सर ये एक दफा आप लाइन की स्टीपनेस समझा देंगे वापस से.
Sorry.
सर लाइन की जो स्टीपनेस है वो आप समझा देंगे.
Yeah, it's very easy. If there is a strong acid or a strong base, then line would be almost a very slightly slant that it appears to be like, uh, almost horizontal. But when there is a weak acid or a weak base, then the horizontal line would be more steeper, like this.
Okay sir, thank you.
So that's what we did in the diagram over here, in the graphs over here. Now, if anyone else have any other question to ask. Yes, is this clear?
Sir,
Yes.
इसमें हमने 14 से क्यों शुरू किया ग्राफ? वॉल्यूम ऑफ NaOH जब हम ऐड करेंगे उस वक्त तो एसिडिक होगा.
Yeah, very good. Thank you, Ariza. I just made the reverse graph. Yeah, we are adding the volume of NaOH. So the line would be at 25, the straight line, and we are adding the NaOH, and initially there was a acid, so it would start from the lower pH and it would end at the higher pH. It would be like this. I just made a wrong graph. And here again, the vertical line at 25, I have to keep in mind that the end point, the midpoint of the vertical line would be below 7 because it's a, weak base is there. So if there is a weak base, so it would be like this. And it's a strong acid, so it would be like this. No, sorry. A little curve. Yes. 1 minute. No, yeah, that's fine. Is this clear to everyone? Yes? Yes, if anyone have any question to ask. Okay. So one more thing, in addition to over here, you have to keep this thing in mind, that which volume, which substance is there on the x-axis. So if it's an NaOH, a base on the x-axis, then it means that the flask already contains the acid. So we would start with the pH of acid, right? And if, for example, here instead of these bases, if there are acids, so it means the conical flask already contain base. So we would start from here. Then that case we would start from there. Okay.
सर तो मतलब 10 और 12 के बीच में क्यों 12 और 14 के बीच से क्यों स्टार्ट करेंगे?
See what we have decided, it's a weak base, right?
अच्छा सही.
So the pH would be lower for the weak base and the pH would be higher for the strong base.
और अगर वीक एसिड होता है तो 2 और 4 के बीच से स्टार्ट करता है.
Yes, then we would start it from like this, and it's not that much horizontal, it would be like this.
ज्यादा हॉरिजॉन्टल होगा वीक एसिड.
Yes, and it would be steeper as the weak base is steeper.
सही.
Okay. Now, HBr reacts with propene to form two bromoalkanes. Okay. Complete the diagram to show the mechanism of the reaction of HBr and propene to form the major organic product. And what will be the major organic product? If you recall that the major organic product is the one which have a more stable carbocation formed, right? Okay. What they are saying, okay, we have to
ये
complete
एडिशन
the
रिएक्शन है ना?
mechanism. Yeah, it's an addition reaction, electrophilic addition. We have to include charges, dipole, lone pairs of electrons, and curly arrows as appropriate. Draw the structure of the intermediate and the major carbocation. Okay, if you see over here, we have to just think of these two carbons which have a double bond. Either this one is going to become a carbocation or this one is going to become a carbocation. If the right one becomes a carbocation, it have a two hydrogen bonded to it, so it would become a primary. And if the left one becomes a carbocation, there is a one hydrogen and a one carbon chain, which makes it a secondary. So this one is the most stable one, right? So it means that this one, the
ब्रोमीन
carbon on the
सेकेंडरी
left
पे
of
जाएगा
the,
और हाइड्रोजन प्राइमरी में जाएगा.
yes, so the carbocation would be this carbon. So what we would do, first we would make a dipole, then we show a curly arrow starting from the carbon-carbon double bond pointing towards the hydrogen, and then another curly arrow from the hydrogen bromine bond towards the bromine. As a result, we would get an intermediate, and that intermediate would be first, let me write all the hydrogens. So the hydrogen is going to be bonded on this carbon, making this carbon a carbocation, and here we got a bromide ion with a lone pairs because it took away the electron from the hydrogen as well. Now, in this step, from this lone pair, I would make a curly arrow pointing towards the carbon. And then arrow. And what would I get? I already have a 3 hydrogens bonded to this carbon. This carbon have a 1 hydrogen and 1 carbon. That is further bonded to a 3 hydrogens. Here the bromine is going to be bond. So that is your product, right? So this is the mechanism for the major product. Now what they are
So
saying
इसमें minor नहीं दिखानी होती.
No, they didn't ask you. See, in the mechanism, we always show the major. There is no need to draw the minor one, okay?
एक मिनट थोड़ा zoom out करिए.
Yeah. Okay. Now, explain why the two bromoalkanes are not produced in equal amounts. Obviously, the one with a major would form in a greater amount. The one with a minor would form in a lesser amount. So the reason is that we have seen that for a major product, the carbocation is secondary, the intermediate carbocation, right? So we can write that the secondary carbocation is more stable than primary carbocation because
रोज आपने एक रूल की डेफिनेशन लिखवाई थी यहाँ पे वो लिखना है.
no, that is not the reason. They are asking you the reason. That is the shortcut way of identifying which one is the major product. Okay, that is Markovnikov's rule. So that is not the explanation, that is the rule. So it is a shortcut way to identify which one would be the major product. But for whenever they ask you explain and ask for the reason, you have to write the stability. So carbocation, because secondary carbocation have more alkyl groups and hence greater positive inductive effect. Yes, is this understandable to everyone?
Yes.
Now the next part. The reaction of bromopropane with NaOH is different depending on whether water or ethanol is used. Yes, if you recall, with water, a substitution or a hydrolysis would occur. And with ethanol, elimination would occur. Complete table 3.2 to identify the organic and inorganic products of the reaction
वाटर
of
के
group.
साथ सब्स्टिट्यूशन में होगी.
Yes. When we use aqueous NaOH, the OH substitutes the bromine. But when we use ethanolic NaOH, the bromine is removed and from the neighbor carbon, hydrogen is removed and there is a double bond between those two carbons. So if we are using aqueous sodium hydroxide, our reactant, that is CH3, CH2, CH2Br would turn into CH3, CH2, CH2OH, and inorganic product would be NABR. Is this clear? Yes. Now, when we use ethanolic NaOH, it would be CH3, CH double bond CH2, and actually, if you see, it's a sodium hydroxide. So what we have discussed, that HBr would form, and that HBr reacts with this NaOH to give you NABR and H2O.
सही नीचे
So then,
एलिमिनेशन हो रही है ना
yeah, NABR and H2O would form. Is this clear? Yes, is this clear to everyone?
जी सर
Okay. So we have ended the question. Now we have question number 4. Compounds J and K are found in plant oils. Okay. If you see at J, there it's a ketone, right? Here it's an alcohol. And if you look at more preferably, it's a secondary one. And this one is an aldehyde. If you look at K, there is a alkene. And there we have a carboxylic acid, right?
ये अल्कोहल टर्शरी क्यों नहीं है जे वाला
Yes. Yes, it's tertiary. All the 3 carbons are there. Complete
जैसे
table
कार्बन
4
के साथ
point.
दिखते हैं ना कि एच नहीं है
Yes.
दूसरे
Yes, because if this alcohol is bonded to this carbon and on the rest of the 3 bonds are with the carbon, then it's a tertiary. Okay. Okay. So what would you observe when J reacts with the reagents listed? Okay. So 2,4-dinitrophenyl. If you recall, 2,4-dinitrophenyl reacts with the ketone and aldehyde both, and the observation would be orange precipitates. So here I'm going to get the orange precipitates because in J we have both the aldehyde and ketone. So this 2,4-DNPH goes positive with aldehyde and as well as ketone. If you recall, Tollens reagent would go positive with aldehyde but does not react with a ketone. So if you see, J would have an aldehyde. So the observation for the Tollens reagent is a silver mirror or a silver precipitates. Okay.
सही हमने कौन से टॉपिक में पढ़ा था
Organic and specifically in carbonyl, aldehyde and ketones. Let me tell you this. If you are going through the lectures, you are going to find this in file number 14, carbonyl. See over here. This is Tollens reagent. Observation: if aldehyde is present on heating with Tollens reagent, silver precipitates are formed. And here you go, 2,4-DNPH test.
जी सर और वो जो हम वो अभी एसिड बेस वाला ग्राफ वाला पढ़े थे वो किस में पढ़ा था
Equilibria.
सही है
You can go over the file of ionic equilibria. See over here. Here we have discussed the shapes of the graph: strong acid, strong base, then weak base, weak acid, then weak acid, strong base, and then weak acid, weak base. Okay.
सही
Okay. So sodium metal. Sodium metal reacts with alcohol and carboxylic acid both. But if you look at over here, J contains an alcohol. So if J contains an alcohol and we are adding sodium metal, the reaction would occur. And in this reaction, the bubbles and the effervescence are seen because of the release of hydrogen gas. Okay. Now what they are saying, J has two optical isomers. Draw the three-dimensional structure of the two optical isomers of J. If they are talking about two optical isomers, which means that there must be a chiral center. So if you see, yeah, this carbon is a chiral center, right? So if I have to draw the optical isomers, so I will write one C in the center, two bonds on the plane, and one bond above the plane, one bond below the plane. The same thing I would do on the opposite side. Two bonds on the plane, one bond above the plane, one bond on the plane. There is a OH group. So I would write them that they should be observing as the mirror images. There is an aldehyde group, right? Beside this,
सर
they have
ऑप्टिकल
one,
वाले में मिरर इमेज बनती है
yes, there is one
और
CH3
सर
group.
3D वाले इसका कोई रूल क्या होता था कौन सी दो चीजें साथ होती हैं कौन सी नहीं हो सकती
This, the above the bond and the above the plane bond and the below the plane bond must be adjacent to each other, the bold one and the dotted one.
सही है
And then COCH3. So if I'm writing COCH3, then I would write COCH3 like this. So the optical isomers are formed, which are the mirror images of each other. Okay. Now, if you see over here, B part, K is used to make addition polymer perspex. A synthesis of perspex is shown in the figure. Okay. So first reaction would occur, and in the reaction two perspex is formed. Identify L. In reaction one, we have used one L and the conditions required for it. So if you see, this is actually changed by this one. So here it was an acid and here it's an ester. So we know that acid reacts with an alcohol to form ester and there is a one carbon. So it means that L must be a methanol, that is CH3OH. So the OH from the acid and the H from here is removed and OCH3 is going to bond over there. So L is a methanol, CH3OH. And if you recall the condition, we use sulfuric acid as a catalyst and we need heating. So these are the condition. Now what they are saying, draw one repeat unit of addition polymer perspex. So this is the polymer. So it means that M is actually the monomer. So if we have to draw the one repeat unit from the monomer, so I would repeat the monomer, but without a double bond. Instead, I would show a single bond over there. Then we made an empty bonds on both the sides to show the repeat unit. Is this clear? Yes. Okay, next part. Use information from table 4.2 to suggest how the infrared spectra of M and perspex would differ. Explain your answer. So if you see over here, in M there is a C double bond O. So let me write over here. There is a C double bond, sorry, not C double bond O, C double bond C is there in M, right? Here is M. Yeah, here is M, here we have a C double bond C. If we compare these two, so what is the difference? There is only one difference, that M have a C double bond C and its polymer doesn't have a C double bond C. So the difference would be over here, that if you see that C double bond C would show the absorption at 1500 to 1600 centimeter inverse. So here I would write that what would be the name? Perspex. Perspex cannot show absorption. Instead of absorption, you write signal as well, at 1500 to 1680 centimeter inverse as perspex does not have a carbon-carbon double bond. Yeah, it's understandable to everyone. Okay. K can be made from a propanol in the three-step synthesis in figure 4.3. So if you look at step 1, it is a nucleophilic addition where HCN is the reagent and KCN is the, you can say, catalyst. Okay.
सर
And
उल्टा
for
नहीं होगा?
what?
एच HCN ऐड होता था और KCN reagent होता था.
No, KCN is a catalyst, HCN is a reagent. And instead
Okay.
KCN, I would use NaCN as well. So there is a change occur over here. If you look over here, there is a carbon nitrogen triple bond over here, and which turns into carboxylic acid, which simply means that it's a hydrolysis. And for hydrolysis, we need aqueous hydrochloric acid or a sulfuric acid. And we have to warm the reaction mixture. Then this is actually turning into this one. So I can easily say that it's an elimination. Why it's an elimination? Because of one hydrogen from here. Sorry.
Alkene बन रहा है.
Yes, and the OH from here is removed. And as a result, there is a double bond between these two carbon, making K. Is this clear? And for this removal of water, here we normally heat it with aluminum oxide. Okay, now what they are saying, identify the reagents, uses and type of reaction in each step. So in reaction 1, we have used HCN. Or no, not or, sorry. HCN and NaCN. type of reaction is so the type of reaction is nucleophilic.
सर अगर हम सिर्फ एडिशन लिख दें न्यूक्लियोफिलिक या इलेक्ट्रोफिलिक नहीं लिखें
Yes,
तो
they have
कुछ
just
मार्क्स
asked you the
कटेंगे?
type of the reaction, so you can write addition as well. In reaction 2, we are using hydrogen ions, we are using acid, so you can write sulfuric acid as well. And the type of reaction is so the reaction 2 is hydrolysis. In reaction 3, they have given us the reagent that is aluminum oxide, and we know that it's an elimination or dehydration.
अच्छा सर H प्लस H2SO4 या HCl तीनों में से कोई एक भी लिख दें तो चलेगा ना?
Yes. So here we have ended this paper. That is February, March 2022. Now in the next class, that would be, I do try to do the class tomorrow, but